Coefficient of correlation. Coefficient of correlation and determination are the most important concept in this chapter. A coefficient of correlation is a measure of the strength of a linear relationship between two variables x and y, and is computed by this statistic. The coefficient of correlation includes a term that is the sum of the square of the first variable respect to the mean of the first variable. Also, the sum of the square of the second variable respect to the mean of the second variable. Remember, for each member of the population, we measure two variables. And in the numerator, we have the sum of all product of the deviation of the first variable respect to the mean times the deviation of the second variable respect to the corresponding mean. In the next slide, we have the graph for several populations. The members of the population are represented by points. We plot each point in the graph according to the measurement of the first variable x and the second variable y. Then for each member of the population, we obtain a pair of numbers, ordered pair as in algebra. And they can obtain the mean of all x that should be located approximately in the middle, and the mean of all y that should be located in the middle. Then we can locate in the middle of the cloud a member of the population or a point that have as the first component the mean of the first variable, and as the second component the mean of the second variable. Then when we have a cloud of points that are distributed around the center symmetrically in all directions, we can obtain for each point the product of the first component respect to the mean of the first component times the second component respect to the mean of the second component. Some of this product will be positive, another will be negative. But when we sum all of this product for all points, the sum should be equal 0. But when the points are located exactly on one line, that is, the slope is positive, then the coefficient of correlation will be equal 1, a perfect correlation. In this case, when the slope is negative, when x increases, y decreases, when all points are located in this line, the coefficient of correlation will be equal -1. In this case, is equal 0. And in this case, and this case is a value close to 0 or close to 1, actually -0.5. That is the idea of coefficient of correlation. In those cases, the coefficient of correlation will be 0 because the coefficient of correlation only measures linear relationship. In this case, we have no linear relationship. Despite of we have a relationship between the two variables, in this case is a parabolic relationship. When we compute the coefficient of correlation, we are going to obtain 0 because the relationship is not linear. Okay, let's do one problem about coefficient of correlation. And legalized gambling is available on several riverboat casinos operated by a city in Mississippi. The mayor of the city wants to know the correlation between the number of casino employees and the yearly crime rate. He wants to know the relationship between casinos and crime rate, but casino alone is not a good variable. Then we need to find something in casino. How big is the casino and how the size of those casinos affect the crime rate. But how can we measure the size of those casinos? We're measuring the number of employees that we have in this casino. Then let's find the relationship between these two variables, the casino employees and crime rate. That is the data. We want to know the relationship between these two variables. Then the first thing that we have to do is solve this problem using technology. Then you can send this data to either to Excel and also to StatCrunch. In StatCrunch to know the answer. In Excel to obtain those answers using formula. The software sends automatically this information to StatCrunch. Then in StatCrunch we need to select stat, regression, and in regression, linear regression, and my independent variable is the number of casino. This is the explanatory variable or independent variable. Is located here. Number of casino employees, and the response variable or dependent variable will be the crime rate, is located in this column. Then we click compute and we obtain all the information. Also, if you want to test hypothesis, if the slope is 0 or different to 0, you need to select hypothesis test. Or if you want the confidence interval for the slope, you need to select confidence interval. Remember that at compute. And we have here this information. That is all the data. Here we have the equation of this line. That is the relationship, the mathematical model, which explain the crime rate in terms of the number of casino employees. We have the coefficient of correlation. Coefficient of correlation here, and the coefficient of determination here is the square of this. And this is the standard error of my model. And we have here everything. This is b sub 0, this is b sub 1, and so on. And here we have the sum of a square. This is the total sum of a square. This is the sum of the square of error, and this is the sum of the square of my model. We have everything here. We need to interpret that. Then let's go to Excel, and in Excel, we can send automatically all this information in Excel. First of all, I would like to show you that you can obtain the graph. First, let's select my data. My data is here. I want to obtain the scatter plot of this data. Then insert the scatter plot. That is the scatter plot. I want this scatter plot, and we obtain this graph. Also, if you want, listen, if you want the equation, click any of these points. Right click and add trend line. When you add trend line, then you select this one, that is a line, because you can select no linear relationship, and is given also. And insert, display the equation here, display the equation, and also display the coefficient of determination, which is r squared. Can you see that? You have everything. Then you can do this also in Excel. But we are going to use Excel to verify my answer. Remember, the equation for the coefficient of correlation will be the sum of the square of all xy divided by the square root sum of square of all xx, sum of the square of all yy. This is the shortcut formula for the coefficient of correlation. We need to find this. How can we find this? Actually, we need to obtain, first of all, we need to obtain here the sum of all x equal the sum of all x then we can copy this, the sum of this column in all of these columns that we needed. Then we already have the sum of all y, but also we need the sum of all x squared, but we need to square this value, the first x, and copy this formula here. And we need the sum of all, the square of all y, but we need to square the first y raised to the second power. And we can copy all of this number in all this formula in all of these cells. And also we need the product of x times y. Then x times y. And we can copy this formula here. And we have we have everything there. Everything is there. Then how can we compute the sum of a square of all xx? Remember, the sum of a square of all xx. Remember, the sum of a square of all xx is given by the sum of all x squared minus the sum of all x squared divided by n. How many information we have here? We have from 2006 to 2015, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 years. 10 years of information. Then the sum of all x squared is located in this row, in this column here. That is the sum of all x squared minus the sum of all x is located here, raised to the second power divided by 10. That is the sum of all xx. The sum of all y, remember, is equivalent to the sum of the square of all x is equal the sum of all y squared minus the sum of all y raised to the second power divided by 10. And the sum of all xy is located here. The sum of all x times y, excuse me, we need to start with equal. The sum of all x times y minus the sum of all x times the sum of all y divided by 10. We have everything. Then we can compute B1, B0, and R. How can we compute R? Is equal the sum of all xy located here divided by square root inside the sum of all xx here times the sum of all xy here. Close parenthesis, and we have our coefficient of correlation. And coefficient of determination is the square of this. Is the square of this. That's it. We have everything. And also we can obtain the sum of all square. We did it in the other exercise, but that is information that we need right now. Okay, let's go to show our work. How can you show your work? Remember, first of all, do the problem in StatCrunch, and in Excel you can do it. You could obtain the equation of the line, you can obtain R squared, and you can obtain this information in StatCrunch. All information is there. The coefficient of correlation is this value, coefficient of determination is this value, and that is the formula for the coefficient of correlation. We need to substitute all of this value. We need to bring this information in Excel and this other information that we obtain in Excel, and we substitute only. How can we obtain the sum of square of xy? This is the shortcut formula. The shortcut formula, the sum of all xy, 800, minus the sum of all x, this value, times the sum of all y divided by 10, and so on. We can obtain the sum of all squares here. Then we substitute all of this value in this equation, and we obtain the answer. That is your work. That is the work that you need to show in the final test. You can use technology, but you must pretend that you don't use it. That is, you need to write down in one paper all of these values. Okay, how can you interpret the coefficient of correlation? Because this value is close to 1, that implies that the relationship between the number of employees of a casino is related with the crime rate positively. Then when X increase, Y increase in this way. That is the meaning of the coefficient, and really is very, very close to 1. It's a strong correlation. It's not, when we graph all points, several years, crime rate and number of employees, all of these points will be actually close, very close to the mathematical model. It's not something like this, because that indicates that the coefficient of correlation is close to 0. But my points are very close to the line in this trend, positive. Another important thing that you need to take in consideration here, that if there is a strong correlation, like as in this case, a strong correlation between the number of employees and the crime rate, despite of this, that doesn't imply causality. Actually, the number of employees is not the cause of the increase of crime rate. These two variables are correlated. When one increases, the other also increases. When the one decreases, the other decreases. But actually, the reason, the cause of the high crimes rate is not due to employees. If the number of casino employees were the cause of the increase in crime rate, then the mayor of the city can say, okay, it's easy, let's control the number of employees, then we can control the crime rate. But that's not true. Gambling, the main activity in casino, is very attractive for criminal minds. The presence of these people increase the crime rate, but not the employees. However, the activity in casino is correlated with both variables, crime rate and number of employees. And another important thing is, if you find that there is no correlation between these two variables, it's possible that when you do the scatter plot, you will obtain one scatter plot like this. That is not a linear correlation. Then is a non-linear correlation. However, the coefficient of correlation for this cloud of point will be close to zero. It's not close to -1 or +1, it's close to zero. Then we cannot jump to one conclusion when the coefficient of correlation is close to zero, state that there is no relationship between these two variables, because really there is a relationship between X and Y, but it's not linear, okay? It's very important to take in consideration these two aspects. And let's finish here.